Large language model, aka LLM, is like a Dory. Do you remember Dory, the adorable and forgetful blue tang fish from Finding Nemo? She was incredibly smart. She could even read English. That's smart for being a fish, but she had one quirk. She would forget what she said just a moment before. LLM is just like her. It's incredibly smart and capable, but it does not remember a thing about the prompt or its response a moment after. Hello, everyone. Welcome back to Data Lingo Solutions Deep Dive series, where we demystify complex AI concepts, transforming them into clear, understandable content for enthusiasts and experts alike. In this two-part series, I will explain how a simple and innocent fix to this big problem of yesteryear is shaping today's and tomorrow's AI industry. Here is what happens behind the scenes when you send a prompt. You are here using either a screen interface on your phone or laptop or your voice assistant interface. You raise a prompt, and pat comes back the response. That's what you feel. Behind the scenes, your prompt reaches an LLM server over the cloud, and the response is returned. The moment the response leaves the LLM server, it does not remember a thing. It does not store the prompt or the response. It is by design. The technical term for this behavior is stateless. The reason for this behavior is to save precious memory for its knowledge over mundane discussions. With this setup, the drawback is that we cannot have conversations. In order to have conversations, we need to remember our previous interactions. Do you agree? For example, I say, "Hey LLM, what's the capital of France?" And the LLM says, "Paris." And then I say, "What are the tourist spots there?" LLM, being a Dory, will say, "Tourist spots? In which place?" Duh. But this does not happen today. We can have conversations all we want with LLMs. So, how is this problem solved? It's solved by a construct called context. The solution is so profound that context not only solved the LLM's conversation ability problem, but is also the bedrock behind two revolutionary trends that is shaping up the AI industry: RAG and agents. That is why I call this the magical context. Let's take a closer look at the LLM flow again. The LLM and the interface are still there, so are the prompt and response. But when you examine it closely, there is this new component called vendor cloud. You will see that the prompt first reaches the vendor cloud server before it gets to the LLM. Response also the same way. First reaches the vendor cloud before getting to the interface. The role of vendor cloud is very important. So let's understand that first. The technical term for vendor cloud is middleware. The vendor cloud acts as a sidekick to the LLMs. It is provided by the solution vendor, which interacts with LLMs like OpenAI, Anthropic, Google's, etc. In the case of ChatGPT, both the vendor cloud and the LLM are provided by OpenAI. For Gemini, Google provides both. However, this need not always be the case. Let's consider an example where the vendor cloud is different from the LLM provider. Amazon recently announced that they are partnering with Anthropic to use their Claude LLM in conjunction with Alexa. Here you are speaking to your Alexa device. Alexa converts your voice command to a prompt and sends it to Alexa Cloud. Alexa Cloud will in return sends the prompt to the Claude LLM server. And when the response is received, it gives it back to the Alexa device. Vendor Cloud acts as gatekeeper and keeps track of all prompts and responses that pass through. Vendor Cloud can adjust the prompts and the response such a way that the vendor can inject their business value. For example, Apple ensures that Siri does not send any privacy sensitive information to GPT. This is controlled within their Apple Cloud. Salesforce Einstein Cloud can add its secret sauce to ensure the prompt is secure and to watch for hallucinations in the responses. The vendor cloud is where our hero of the day, magical context, also manifests. Let's get on with it. To understand LLMs, I always think of them as subject matter experts, like lawyers, doctors, or engineers. Let's assume this gentleman is a lawyer. He has vast knowledge and wide experience. When you visit him, he already knows your name, your likes, dislikes, your earlier conversations, everything about you and your case. You might be wondering, how is that even possible, given that he has thousands of clients like you? Now, say you bump into him in a supermarket the very next day. He wouldn't remember a thing about you. Why is that? Because these experts make notes on what has been discussed at the end of the meeting and review those notes before the next meeting. That is the sheet of paper you see on his desk. When you bumped into him in the supermarket, he didn't have that refresher. Simple trick that works. That is exactly how this problem is solved in the case of LLMs too. Vendor clouds perform many functions. At the base level, they act as gatekeeper for all prompts and responses. When a new prompt arrives, the vendor cloud attaches the previous prompts and the responses to the current one. This is known as context. The vendor cloud then hands over the prompt and the entire context to the LLM. LLMs are designed to give higher attention to the prompt first, context next, then to their own knowledge base. This allows the LLM to craft more relevant and contextual responses. The net effect is that we perceive the LLM as conversational. This trick of providing context to get better responses is not a rocket science. Human beings, including the lawyer we took as an example, have been doing this intuitively for ages. It is obvious, natural, and effective, and it works. Moreover, it turned out to be very profound. Before we delve into that, let's understand a few nuances. When we have conversations, we not only remember what we previously discussed, we also remember the order of our discussions. Unless you are in a presidential debate, our attention in a conversation is usually focused on what was said most recently rather than something from earlier, isn't it? Similarly, the context provided to the LLM is arranged in reverse order of the prompts and responses shown on the interface. This allows the LLM to pay closer attention to the latest prompt. Look at the asterisk mark right next to the prompt here. That represents the latest prompt. That always remains on the top. Next come the previous response and prompts in chronological or reverse order. The technical term for this kind of arrangement is called a stack. Let's take my earlier conversation example of finding out the tourist spots in Paris and see how the context is arranged. My first message was, "Hey LLM, what's the capital of France?" The same message go on the context that is provided to the LLM. Next comes the response, Paris. On the chat box, we see that right below my prompt. However, in the context, response is placed above my prompt. Remember, I mentioned reverse order. Next, I typed in, what are the tourist spots there? Observe that my second prompt is at the bottom of the chat box, but attached to the top in the context. When the LLM look at my prompt, it gets the question, where? Then it looks at the previous response. It realizes, oh, I'm referring to Paris. So it can come up with a response like this. If you find this information useful, please like and share it with others who might benefit. Please consider subscribing to the channel and hitting the bell icon below to get notified whenever we release a new video. Coming to nuance number 2. We saw how messages get prepended as we have a conversation with the LLM. The next question is, how many prompts and responses will it append? It cannot go on forever. Can we keep track of conversations forever? No. So, what is the cutoff point? The term for this is context window. It measures the size of the context in terms of tokens. Each token is roughly equivalent to 3/4 of a word or about 4 characters. It is an important indicator of the LLM's quality. Just like each of us has our own threshold level of how much conversation we can keep track of, different LLMs have different capacities. In fact, there is a context window size race among LLM vendors. For example, Llama 3.1 has a context window of 128,000 tokens, roughly equivalent to 24 pages of Word document. Claude 3 has 200,000 tokens. Gemini boasts over 1 million tokens. But what happens when the context size hits the context window's maximum limit? When the context size reaches the maximum allowed size, it has to be pruned. You can imagine pruning as something you choose to forget from your attention span. Context pruning strategies are a hot topic and can be divided into 3 main categories depending on where the pruning is happening. The easiest and most widely used strategy currently is chronological pruning in the vendor cloud. In this approach, the vendor cloud provider removes the earliest prompts and responses, just willy-nilly cuts it. While this is simple, what if important information is contained in those early parts? For example, in my presentation today, I mentioned the subject for today's session. If you forget that piece, you lose the direction of the discussion, right? It's not ideal, but that's what is widely used as of mid-2024. New strategies are being developed. Another approach at the vendor cloud level is to find only the relevant portion in the context related to the newest prompt and send only that part to the LLM. This technology is called RAG. We will discuss RAG in the next part of the video. For now, just understand that RAG filters out all irrelevant portions from the context. This has to be done for each prompt though. So the responses are slowed down a bit. Another strategy is to use LLMs for pruning. Using LLMs, the context can be summarized without losing the vital parts. This is a growing field and is still in the R&D stages in mid-2024. New ideas such as building external devices, databases, or even mini LLMs are being considered. You can find links to these research papers in the description below. Finally, there is one simple trick we users can do to manage context sizes better. Maintaining context hygiene. This is our third and final nuance. There are two ways we can maintain context hygiene. First, cut out all the junk. If we have junk in our prompts, we will have junk in our context, producing poorer results. So we have to be careful about what we prompt. Watch my earlier video, Help Your Copilots to Help You, to understand how to prompt smartly. Second, maintain a separate thread for each topic. Just like how we get confused when a conversation jumps from one subject to another, the LLM can also get mixed signals and generate poorer responses if topics are mixed up. How can we avoid this? By having a separate thread for each topic. Each thread will have its own context focused solely on that topic. For example, I have a separate thread for writing help, which includes prompts and responses related only to wordsmithing. Another thread is dedicated to prompts about Python programming language. Additionally, there is a thread for finance-related prompts. By maintaining these separate threads, only prompts and the responses related to the specific topic will be present in the context. Of course, at some point, the context window will reach its maximum size, but it will take longer to do so. Moreover, maintaining separate threads not only improves the quality of responses, but also helps managing costs. The cost is proportional to the context size. The larger the context, the more data the LLM has to process, and you are charged for whatever the LLM processes. While the cost may seem small initially, it can add up without you noticing, leading to a bill shock. Thank you for joining this session of Data Lingo Solutions. Let's capture some takeaways to conclude part 1 of the magical context video. LLMs remain stateless, meaning they are forgetful, much like Dory from Finding Nemo. Thanks to context, which plays a major role in enabling LLMs to have conversations. The size of the context, also known as the context window, is one of the major metrics that defines LLMs. LLMs are designed to pay higher attention to the latest prompt and previous responses in reverse order of their receipt. This helps in maintaining a conversational flow. The magic of context does not end with just aiding in conversations. It provides a great mechanism to manipulate the LLM's attention. Both RAG, the current revolution shaping up AI products and agents, the AI workers that represent the next big revolution, depend on this trick of manipulating the LLM's attention. Let's get a quick understanding of how context plays a pivotal role in these two highly impactful technologies in part 2 of this video. If you found this session helpful, please subscribe to our channel and hit the bell icon to stay updated with our latest videos. Feel free to leave your questions or comments below. We would love to hear your thoughts and suggestions. Thank you for watching and see you in the next part.